Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform. Let me check the things and then I'll start. So I welcome you all to this session of casting part 3, which we have been started. Okay, so audio, video, everything is good. So keeping this aside, good evening Shivam, good evening, good evening. Hello everyone. So welcome to the platform of Unacademy, which is India's largest online learning platform, where we are actually studying casting. Okay, so those who are new to this channel, my name is Vidyapati Kumar, and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University, and my specialization was production. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research paper publications, which are actually national and international journal of repute. So this is actually a casting part 3, and we have already seen the 2 subsequent parts of the castings. So you can download the Unacademy Learning app because Unacademy Learning app has a lot of advantages. So there is a free courses there as well as paid ones there. So if you are going for a plus subscription, then you are getting the benefits. So for the free courses here, a lot of educators, almost all the educators publishes free lessons, and I am publishing the free lessons of strength of material. So you should download the Unacademy Learning app because daily live classes are there. A lot of educators publishes their daily live classes. Courses are structured in manner as well as unlimited access of the contents are there. You can always go and attempt the tests and the quizzes. So these are the some of the benefits of the free courses of Unacademy Learning app. Now there is one plus subscription in which there would be a complete coverage of the syllabus. Complete coverage of the syllabus would be there 100%. So you should go for that. Daily live classes are there, top educators are there at that plus subscription panel, and at there you get the ample of uh, choices to study from a lot of educators, from what educators you want to study. So these things are there. आपके पास बहुत सारा ऑप्शंस रहता है, आप जिससे चाहें उससे पढ़ सकते हैं. सारा कंटेंट, सभी कोर्स मटेरियल, मॉक टेस्ट, practice tests, सब कुछ का एक्सेस होता है. So these are the benefits of that, as well as courses are structured in manner. So these things are there. और सबसे बड़ी बात है कि कंप्लीट कवरेज होता है सिलेबस का, और एक सब्सक्रिप्शन में, फॉर अ सिंगल सब्सक्रिप्शन, यू आर गेटिंग द बेनिफिट ऑफ गेट as well as engineering service examinations. So both are there. So these are the top educators of the panel. And for GATE and ESE, Unacademy has a lot of courses, batches for mechanical, CS, IT, civil, production, industrial, everything. Now, if you're planning for that, for a 12 months plan, it would cost around 25,000. And if you will use my code SIRVK, then the discounted amount would be 22,500. For 6 months, it would cost around 20,000. But if you use my code, then again you will get a 10% off. So you will get a 10% off if you are using my code SIRVK. Similarly, for a 24 months plan, it would cost around 30,000. But when you will use my code SIRVK, then again you will get a 10% off on the amount. So I think investing these things are very much cheaper. As you can see, 37 rupees per day investment is there, or 60 rupees per day investment is there. If you are doing these investment are worth it, so you should go for that. Until now, we have been studying in this YouTube platform casting. We have already covered the metal cutting, and this is the casting third part. So this session, today's session is going to be little bit short. That is not going to be हर दिन की तरह वो बड़ा नहीं होगा, but छोटा होगा. But still we are going to cover a lot of good topics today's. Good evening Mukta. Hello Dexter. Good evening Indrajit. चलिए, okay, चलिए देखते हैं. Let's start our session. Okay, so let's start our session now. Good evening Asis, good evening. So now, in the earlier class, yesterday's class, what we have seen, the permeability, concept of permeability. Okay, so in the earlier class we have seen the concept of permeability. And in this concept of permeability, we have already seen that there is a number known as permeability number. This permeability number, I have defined this permeability number, as well as I have given one good equation relating this permeability number, which is R is equal to VH by PAT, where I have already mentioned that V is the volume of air, which is around 2000 centimeter cube. H is the height of the sand specimen, which is 5.08 centimeter. Next is the pressure. P is the pressure, air pressure. And most importantly, we are going to measure this air pressure in terms of gram per centimeter square. Okay, and A is the area. So A is the cross sectional area of sand specimen. And what is the area we have seen yesterday? That is 20.268 centimeter square. So these are the standard specimen. Okay, हमने एक स्टैंडर्ड बनाया और हमने इन चीजों स्टैंडर्ड चीजों पर ये चीज करके देखा तो क्या परमेबिलिटी नंबर आया. व्हाट इज द परमेबिलिटी नंबर दैट वी आर गेटिंग. ओके, एंड व्हाट इज द टी सर? टी इज द टाइम. Most important, time should be in minute for complete air to pass through. Okay, and when I have put these figures of v in this equation, h in this equation, a in these equations. Okay, so v is like 2000 H is like 5.08, P is as usual, A is 20.268, 20.268, and T is T. So when I have put these figures, I've got 501.28 into PT. So this is what is the R. This is what is the R. Clear? So, so this is what is the R, which is permeability number. These things we have seen in earlier class. What is the most important thing? That when you are calculating the pressure, it should be in gram per centimeter square. Next thing is what? When you are calculating the time, it should be in minute. Okay, it should be in minute. So these things should be always in your mind, and then you can able to solve the questions. Good evening, Mayur. Good evening. Now, if these things are in your mind, then please try to solve this question. Please try to solve this question. Please try to solve this question. In this question, permeability number has been asked to calculate it. If these data are given, find the permeability number and tell me the answer. Find the permeability number and tell me the answer. Find the permeability number and tell me the answers. Try to find it. Just now I have explained you the concept of permeability number. Just revise the data what we have seen in yesterday class. Okay, so I'm getting 80.204. Okay, kindly check your figures. Kindly check your figures. बाकी लोगों का क्या हाल है? 70.76. Okay, anyone else? Try to solve it. This is very easy question that I have given to you, and these questions, these type of questions are asked in GATE. See here. Okay, okay, so at least you are trying. So see here, in this what has been told, calculate the permeability number of a sand if it takes 1 minute 25 seconds. So what is the time here? Time is 1 minute 25 seconds. Clear? To pass a 2000 centimeter cube of air at a pressure of 5 gram per centimeter square. So what is the pressure? Pressure is 5 gram per centimeter square. So throughout the standard sample. So whenever it has been told that standard sample is there, and we know the standard samples volume is what? 2000 centimeter cube, and just now we have seen these things, right? So just we will apply this formula. R is equal to 500.28 by PT. Okay, so R is equal to 500.28 by PT. Now before starting the calculating these things, let us see first of all, let us see that what are the things I have told to you. Pressure P should be in gram per centimeter square, isn't it? So it is in gram per centimeter square, so this is correct. Next is what? T. Time should be in minutes. So for complete air to pass through, time should be in minute. Now first of all, my work is to convert this time into minute. Clear? So now if 1 minute 25 second is converted into minute, it would be 1.417 minute. Clear? So now 1.417 minute is given to you, and you know the pressure. Just put it in this equation. 500, 1.28, P is given as a 5, and T is given as 1.417, and when you will calculate, you will get a permeability number of 7.75, something like that. Okay. uh Mayank ji, I think you will be getting answers around 70.75. Okay, so good. Okay, so ये जो है again same 70.75. Yes, 70.75, it should be 70.75. Clear? So any doubt? I don't think so you will having any doubt. So now we will be talking something about new things. Okay, so yesterday what we have seen, yesterday we have seen some of the properties, right? Some of the properties of the molding sand, like adhesive, green strength, dry strength, permeability, fluidity. So these things we have seen in yesterday's class. Now what we are, I thought my answer was wrong. No, Asis, answer was right. Answer was right. See, only thing that you have to keep this in mind. See here, only thing that you have to keep in mind, again I am telling you, again, for those who joined this class just now, so again I am telling you, what you need to always keep in mind, that sir pressure जो है, pressure ग्राम पर सेंटीमीटर स्क्वायर में है या नहीं. Next is time is in minute or not. Just these two things are clear or not. If these two things are in own units, you will be getting the correct answer. Now what we are going to see, we are going to see molding sand composition. That this molding sand is made of, what are the materials through which these molding sands are made of. Okay, now see, the main ingredient I have already told you in yesterday class. See, what is the thing that I have told you, that first is base sand. Okay, base sand is there. Second is binder, and third is moisture. Okay, third is moisture. हाँ प्रतीक जी बताएं, what do you want to say? So first is base sand, binder, and moisture. See, what is the base sand? What is the base sand? See, base sand has three things. First is silica sand. Next is next, what is we are adding? Other base sand. Other base sand. And third is, so we are going to see these things step by step. Okay, so let us see. So what is base sand? What is base sand? So actually base sand is made up of silica sand, है ना? Silica sand से बना होता है base sand. And see, what we can say, that it is made up of silica sand, which is actually the most commonly used base metal, base sand. Now see, other base sands are what? Apart from silica, we have zircon, we have a lot of other base sands. So like other alternatives are what? Other base sand. So what are the other base sand apart from the silica that is used in this, is like zircon sand, chromite sand, and olivine sand. See, only you just go through these notes. You don't need to remember everything. I'm again telling you, you need not to remember everything. रटना कुछ भी नहीं है सर. एक बार नोट्स को अच्छे से पढ़ लीजिए एंड यू विल बी एबल टू सॉल्व अ लॉट ऑफ क्वेश्चंस. ठीक है, तो मैं आपको जो नोट्स दे रहा हूँ ये सब आप अच्छे से एक बार पढ़ लीजिएगा. ठीक है. थर्ड पॉइंट इज व्हाट? थर्ड इज सिलिका सैंड. Silica sand is actually cheapest. Okay, so it is very cheapest and easily available, and hence due to these things silica sands are used as a base sand. Good evening Gaganji, good evening. So now sir, what we have seen, just now we have seen that कि जो हमारा मोल्डिंग सैंड जो बनता है सर, molding sand composition is actually made of three things. Base sand. So base sand we have seen. What is base sand? Base sand is a type of sand that is actually base, right? So here actually silica is there. Main component is silica. Main component of a sand, that is the base, right? So base sand. So that is silica. Now what is binder? What is binder? What is binder? See what is binder. See what is binder. See, binder is an element, right? Just for now, you just keep these things in mind. Binder is an element. What exactly it does? Whatever the materials we put in the sand, right? So this binder actually binds everything with so much of attractive forces, right? So these are some of the powders, some of the elements are there. And what are these elements? What are these elements? So in this binder actually we have clay binder, clay binders. We also have organic and inorganic binders. And let me tell you, the most popular clay binder that you have also used in your workshop technologies classes when you were in BTech, or if you are in a third or fourth year of BTech, you should have seen these things. So what is the name? That is bentonite. How many of you have heard about the name bentonite? Bentonite. Okay, so there is a clay binder which is various in every places. Bentonite is maximum used. Okay, this is the commonly clay binder which is used while casting. Okay, so bentonite. Next is kaolinite. Next is kaolinite. And the formula of bentonite is Al2O3 dot 4SiO2 NH2O, and it's Al2O3 dot 2SiO2 2H2O. So you do not need to remember the formula. The main thing is this. Bentonite. Okay, so most commonly clay binder is bentonite and kaolinite. सो यस, हाँ, तो ये तो बहुत कॉमन चीज है. सो दैट्स व्हाई आई हैव टोल्ड यू दीज कॉमन थिंग्स यू ऑलरेडी हैव seen in your workshop technologies classes. And which type of exam, Arvind? So now see, of the two, from the twos, from the above two, bentonite can absorb more water, which increases its binding power. Okay, so this is more important. What type of exam you are talking about, Arvind? So this was the thing of a bentonite. Bentonite is an element which is actually used to bind the sand element. Everything is to bind it. And in this bentonite absorb more water, and since it is absorbing more water, hence it is increasing its binding power. Now third thing is, see here. So third thing is moisture. Third thing is moisture. Third thing is moisture. See, clay acquires its bonding action only in the presence of required amount of moisture. See, if clay is dry in nature, अगर clay क्या होगा सर, सूखा होगा, तो वो फिर क्या होगा ना, बाइंडिंग पावर उसमें नहीं आएगा, वो जोड़ नहीं सकता है ना. जब वो एक सर्टेन, एक मिनिमम, ए मिनिमम अमाउंट ऑफ मॉइस्चर इज रिक्वायर्ड फॉर द क्ले to bind it. Hence clay acquires its bonding action only if only in the presence of okay, so required amount of moisture is needed to make these things in the bonding. Okay, so now amount the amount of water used should be properly controlled. This is most important, properly controlled. So whatever the amount of water you are giving, it should be properly controlled. And see, molding sand constitutes, I have already told you, the molding sand constitutes these three things: base sand, binders, and moisture, right? See that silica sand silica sand is approximately 85%. Okay, so suppose if the component of the molding, what is there, that is 100%, if the component is of 100%, so in that 100%, silica sand is 85%. Clay, okay, clay, so in that clay, what is the being used? Sodium bentonite. So its weight is around 9%. And see, in these two, what I have told you, that clay acquires its binding action or the bonding action only in the presence of required amount of moisture. So you have to give some minimum amount of moisture so that they can bind with each other, and hence the moisture is required, and the moisture is something around 6%. Okay, so something around these are the figures. Clear? Clear? Okay, now we will see the casting yield at a later stage. Now we can start our new topic, that is gating system. Now till now, if you have any doubt, then please ask with me. कोई प्रॉब्लम है तो मुझसे पूछ सकते हैं. Now we are going to see a new topic, that is gating system. Okay, if you have any doubt, then please ask with me till now. Sir, any doubt? Okay, let's start our new topic, gating system. What yield नहीं सर चलाना? I will talk about that yield part. Okay, See, Asis, we have the numerical section, and see, we have a lot of numerical in this gating system, riser design, sprue design, total solidification time. But मैं जो है ना, मैं धीरे धीरे आपको चीजों को ले जा रहा हूँ, है numerical इसमें. But apart from the numerical, there are a lot of theories also. Let me tell you, in casting there are numericals, but apart from the numerical there are a lot of theories also that are important for your gate examinations. Okay, तो जो भी मैं बता रहा हूँ, everything is important for your gate examinations. So now let's start with our new topic, gating system. Gating system. So what is the gating system? So it refers, yes, ild baki hai, I will tell the ild. Yes, so it refers to all the sections through which the molten metal passes while entering into mold cavity. See here, see in this figure what I have written. सैंड में क्या क्वेश्चंस पूछते हैं, देखिए, समटाइम्स दे आस्क लाइक दिस, समटाइम्स दे आस्क लाइक दिस, दैट which is the most commonly binders that are used. So they may give the answer as bentonite and the kaolinite. So these things they ask, right? These two terms they ask, very important terms are there. As well as they can also ask कि मोल्डिंग सैंड जो है वो क्या किन चीजों से बनता है, बेस सैंड, बाइंडर्स एंड मॉइस्चर. So these things can be asked. And see, from this section directly this type of questions may be asked directly. The time is given, pressure is given. Only difference is that they might give in this question, they might give the questions in Newton meter square. Suppose if they are giving the pressure in Newton meter square, so your duty is to convert it into grams per centimeter square. So these type of questions are asked from these sections till now. Okay, now see, please see this figure, please see this figure. So in this figure, from here you are pouring the molten metal. Okay, so from here this is the pouring basin, and from the pouring basin molten metal is poured. Okay, molten metal is poured, and these molten metal is going through these all parts. Okay, through these all parts. Okay, through these all parts molten metal is flowing, and see, molten metal is flowing through it. And see what is the most important thing that I have written. Molten metal is flowing. What is the most important part that I have written here? It refers to all the sections through which molten metal passes while entering into the mold cavity. See here, mold cavity kahan tha, sir? This is my mold cavity. Before entering the mold cavity, this molten metal passes through every part, right? Every part, like sprue is there, right? Sprue is there, pouring basin, this is the pouring basin, this part is sprue, this part is gate, well, and runner, and everything. So these all things together are known as gating system. Clear or not? Gating system is clear or not? Gating system is clear or not? So in this gating system, what are the elements of a gating system? So we can see in this figure there is a, so this is a pouring basin, so this is pouring cup, right? Pouring cup is there, right? See, this is the sprue, right? So this is pouring cup, clear? So this is the first part. Pouring cup is our gating system part. The second part that we can see here, this is the sprue. When you are pouring the molten metal, it is passing through this part, and this part is known as sprue. So sprue is also my element of gating system. Now see, this part, this small part, this part is known as sprue well. Okay, sprue well. See, sprue well is there, right? See here, this is sprue well. This is sprue well. Clear? Now see, this is a sprue well. So third part of the gating system is pouring cup, sprue, and sprue well. It is also known as sprue well. It is also known as sprue well. Okay, sprue well. And see, it is passing through this part, right? Runner, right? So next part, next important part of the gating system is runner. Clear? Runner. And see, this is also gate. So gate is also known as by one another name, gate or in gate. In gates, I will discuss these things. Okay, I will discuss these things, no need to worry about it. And next thing is what, it is flowing through it like that. Okay, so everything, everywhere molten metal is there. Now see, here also molten metal is there, here also molten metal is there, here also molten metal is there. And this part is known as, this part is known as riser, right? This part is known as riser. So my next part is riser. Okay, so this is open, so hence it is known as open riser. So what I can say here, that what are the parts, if if it has been mentioned that sir gating system क्या है sir, तो sir gating system जो है, it refers to all the sections what we are saying, it refers to all the sections through which molten metal is passing, right? Molten metal is passing from all the things, right? So जिस भी सेक्शन से molten metal pass कर रहा है while entering into the mold cavity, here is the mold cavity, and hence this is known as, these all the things are known as gating system. So what are the elements that we have seen? First element is pouring cup, second element is sprue, third element is gate or in gate, fourth element is sprue well. Okay, this is the fourth element. Fifth element is runner, and the sixth element is riser. Clear or not? This thing is clear or not? Nasik ji, I have started this class at 9:45. Sorry, at 8:45. Okay, so I hope this is clear to you. This thing is clear to you. Okay, now see, now see. So what are the elements? So elements are these all things. Okay, these six things are element. Okay, these six things are element. So let me write it here so that you can have the things. So what are the elements? Elements is pouring cup. Okay, pouring cup. Next is sprue. Next is sprue well. Next is runner. Next is ingates, and ingates are also known as gates. Okay, next is riser. Clear? So these things are clear to you. And see, next what is, next thing is, so we have understood that what is a gating system. Gating system कहते किसको है? What is gating system? This thing has been clearly understood by you. Now in this gating system, what are the elements that makes the gating system? So we have also seen the elements, 6 elements are there. Now what is the objective of this gating system? Gating system बना के हम करते क्या है, और अगर gating system में sprue है, riser है, ingates है, these things are there, so what is the need of that, and why, what is the objective of this gating system? So let us understand what is the objective of the gating system. First of all, we have to understand objective of gating system. Okay, so what is the objective of a gating system? So first objective is design of design the gating system such that liquid metal can be enter into the cavity with optimum velocity within a given time without causing, most important thing that I'm going to write, without causing turbulence. Next is what? Splashing and erosion. See, when you will put the, see, this is the, so see, this is a pouring cup, right? This is a pouring cup. This is a pouring cup. And in this pouring cup, when you are pouring the molten metal, right, from the top you are pouring the molten metal, so there is a chances when you will put the molten metal may splash, right? Molten metal may splash. And see, at random, at random, when you are pouring the molten metal, so what molten metal can do, it will splash and it will erode the sand. It will erode the sand on the cavities whatever you have made, right, due to its high temperatures and these fluidity, right? तो ये सारा चीज प्रॉब्लम होता है सर. तो what is our objective is, so what is our objective is that we have to design a gating system such that liquid metal can enter into the cavity with optimum velocity. Optimum velocity should be there. Okay, optimum velocity should be there, as well as within a given time without causing the turbulence, splashing and erosion. So this is the most important thing. It should have the optimum velocity, as well as turbulence, splashing and erosion should not be there. Clear? Vent means, Sudhir ji, I think you haven't done my class which I have taken yesterday. Okay, so if you have been doing the class, then I think you should not ask this question. But for you, I'm again telling you, vent. What is vent, sir? See in this figure. See in this figure, sir. What is happening? What is happening? What is happening? When you are pouring the hot molten metal from here, right, when you are pouring the hot molten metal from here, then what happens that the hot molten metal traps a lot of gaseous particles, that airs can be trapped inside it, right? And this air particles are actually inside these mold cavity, and these everywhere air get entrapped, right? Now see, to pass it the air, right, to pass the air in anything, we give some extra holes, right? We make some extra holes so that if there is a gas entrapped inside the mold things, so it should escape. So this vent is a type of a hole that we give so that any gaseous particles that is entrapped in the casting can escape out very easily. Clear? Clear? Okay. And Asis and Indrajit sir has already told you. Good, good, good. बढ़िया बढ़िया बहुत अच्छा. Now see, so this is the first objective of a gating system, right? This is the first objective of a gating system. Now see, what is the second objective? What is the second objective? The design the gating elements. Now see, I'm talking about the elements, and just now we have seen what are the gating elements, right? So design the gating elements so that pure liquid metal can be enter into the cavity without air aspiration effect. Now see, what is air aspiration effect? What is air aspiration effect? See here, you can see these things. Okay, so there is a pouring cup, and there is a sprue, right? There is a sprue. Now see, I'm drawing these things here. So this is my pouring cup. Clear? This is my pouring cup, and through this pouring cup, a sprue is there, right? So a sprue is there. So this sprue is this. Okay. So this is the sprue. See here. This is the sprue, right? This is the sprue. Now see what is happening when you will pour the molten metal, right? When you will pour the molten metal, right? When you will pour the molten metal from here, what will happen when you will pour the molten metal? Molten metal follows this like something like this path. So like this molten metal will go. Okay. कुछ इस फैशन में मोल्टन मेटल जाता है, ठीक है. You can relate these things when you open the tap of a water. Then you can relate these things that this tap of water, these things are making the parabolic shape. Now see, when you are pouring the molten metal inside it, then from here what we can see, there is a path which is vacant, and from these path what happens that air 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 can go inside these gaps. Air can go inside these gaps. Okay, so now what we can see from here, that air can pass. Air can pass. And you know what, when you are pouring the molten metal, along with the molten metal, if outside atmospheric air will go inside it, then what it will do, so when more air will be there, it will cause a lot of defects would be there. And see, in yesterday's class, or day before the yesterday's class, I have told you what are the defects they are going to produce. They are going to produce the gas defects. Now see, this whatever the thing is there, right? This process of getting the air, this is known as air aspiration effect. Air aspiration effect. Now see what I have written here. See here, so design the gating element. So we have to design the gating element. So see, what is the gating element here? See, in this figure, so there is a problem in the design with this thing, right? There is a problem in design with the sprue, right? So sprue is what? Sprue is a type of a gating element. So most important point is there, design the gating element so that pure liquid metal can enter into the cavity without air aspiration effect. So I think you have understood the meaning of this second objective. Now what is the third objective? Sir? What is the third objective we have? So third objective is produce the gating elements for maximum casting yield. ओके, प्रोड्यूस द गेटिंग एलिमेंट्स फॉर मैक्सिमम कास्टिंग इल्ड। अभी क्या होता है ना, कास्टिंग इल्ड कहते किसको है, व्हाट इज मेंट बाय कास्टिंग इल्ड। सी हियर आई एम राइटिंग व्हाट इज मेंट बाय कास्टिंग इल्ड। Casting yield. What is casting yield? See here, casting yield can be written as volume of casting. See here, see here, when you are pouring the liquid, right, when you are pouring the molten metal, see only this much amount, only this much amount is your mold cavity. Clear? Suppose only this much amount is your mold cavity. See here, only this much amount is your mold cavity. Clear? But see, mold cavity is very less. Mold cavity is very less. So this is only the mold cavity. And see, mold cavity के साथ साथ, what are the other elements that we are getting? Like these, like these things, right? These things are the other elements that we are getting apart from the mold cavity, right? These things are other things, right? So see, these things are come under the gating system, right? These things are comes under the gating system, and this is what is the known as the casting, right? This is known as the casting. So what I have written here, I have written here volume of casting, volume of casting, which is defined as VC by again volume of casting plus of volume of gating element, let it be VG. देखिए क्या होता है कि जब आप जो है ना, जब आप पोर करते हो, when you are pouring the molten metal from here, when you are pouring the molten metal from here, so you are getting this. When you are pouring the molten metal from here, so apart from the mold cavity में तो मिलता है, ये mold cavity में molten metal जाएगा और वहीं पर तो असल में casting होता है. That is the main casting thing, that is the main required thing. And but apart from this also I am getting these super plus things, right? So extra things we are getting from there. So these extra things are known as gating system, and whatever the volume of this gating system plus volume of the casting, so this is the total volume. So what we can say, so here casting is defined as volume of casting by total volume, right? And hence this is known as casting yield. Hence this is known as casting yield. Now see, what is casting yield? Casting yield is the proportion of the actual casting mass. Actual casting mass. What is the actual casting mass? What is the actual casting mass? Actual casting mass is volume of casting. So density is equal to mass by volume. So if you are talking about the mass, so you have to multiply with the volume of casting into density, right? So you are talking about the weight. Suppose its weight is small w to the mass of the metal poured into the mold. So mass of the metal poured into the mold includes volume of the casting as well as volume of the gating system, and hence it is defined as casting yield is equal to small w by w. So both are same, both are same. It is also defined as VC by VC plus of VG, where what is VC? VC is the volume of casting and VG is the volume of gating system. Clear? So I think these things are clear to you. Okay, ये सब कुछ clear होगा आपका. If you have any doubt, ask me. What is air aspiration effect? These things have been clear to you or not? These things are clear to you or not? Air aspiration effect. Otherwise I will explain these things once more. See here what is happening in air aspiration effect. See, atmospheric gases, like see atmospheric gases can be absorbed into low pressure areas, right? So these are the low pressure areas. So atmospheric gases can be absorbed into the low pressure areas in the gating elements, and these will form the gas defect, right? This will form the gas defect. So see here, what is the thing that we do? What is the thing we do? Okay, good that you are understanding. So see, to avoid to avoid air aspiration effect, to avoid air aspiration effect, ideal shape of this sprue is parabola. Okay, so I have told you, because these are making the parabolic shape, right? These are making as a parabolic shape. See here, these are making a parabolic shape, right? Like this. So this is what, this is the parabolic shape. So if I should draw it here, you have made the sprue like this, you have made the sprue like this, but 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 what you are getting, that when you are pouring the molten metal follows a parabolic path. Clear? So this is what is, actual, this is what is like ideal. See, you can make the sprue ideally like this, right? So that if you are able to make a sprue of parabolic in nature, then there would be no entrapping of the air, and hence you are getting the this ideal shape. But see, the problem is that you cannot make a parabolic sprue, you cannot make a sprue of parabolic shape, right? Because problem is what, parabolic shape banana itna आसान नहीं है sir. It is not very easy, or it is not a very cup of tea like things like that. Okay, it requires a various calculations, and manufacturing is very difficult. Hence this is the ideal conditions. What we do in actual case, we make a tapper, and this is the actual case, this is the actual case. Clear? Now see, that's what I have told you. To avoid air aspiration effect, ideal shape of this sprue is parabola, right? Ideal shape of this sprue is parabola. To reduce the manufacturing, to reduce the manufacturing difficulty, shape of the sprue is considered as taper. Okay, so I hope this is clear to you. So I hope this is clear to you, right? Now see, let us understand some of the things. Let us understand some of the things. What are these things? Kindly see here. Now see, now first part that we have been seeing, so this is our objective, right? So right now we have seen that what is the objective of a gating system, why we are making gating system, because due to these three things, right? Due to these three important salient points, right? Now see, first element is what, first element is pouring cup, second is sprue well, runner, ingots and riser. So let's start with the first element, that is the pouring basin. Pouring basin. See, pouring basin is somewhat like this, right? So this is the sprue, and here this is the pouring basin, right? This is the pouring basin. So ideally, this is actually made like 2.5D, where D is the diameter, and this is making some curvature, and the radius is approximately like 25R. Okay, so these are the dimensions, right? These are the dimensions which is followed in practices to make a pouring basin. And see, pouring basin, it is designed to reduce the velocity of liquid metal which is entering, liquid metal which is entering into the sprue. See here, if there is no pouring basin, right, if there is no pouring basin, and directly when you will pour the molten metal, so what will happen? There is abrupt flowing, right? So velocity will be very much different, so you can find a turbulent flow here. Turbulent flow of the molten metal would be there, and if turbulent flow of the molten metal will be there, बहुत ही बेकार आपका casting बनेगा सर, बहुत ही third class का casting बनेगा. Now see, to avoid this turbulency in the flow of the molten metal, what I am doing, I am first pouring the molten metal in the pouring basin. Now see, once I will pour the molten metal in the pouring basin, so earlier it was having some velocity v, now it is having the minimum velocity is no velocity is there, and at the very easily and very बहुत आराम से these molten metal will flow through the sprue, right? So if this is the condition, so no turbulency would be there, and if no turbulency would be there, then no erosion of the mold would be there, and casting would be perfect. Hence there is a need of the pouring basin. pouring basin का एक need होता है सर, ये चीज समझ में आया या नहीं आया? pouring basin का जो होता है need होता है, right? There is a need of this pouring basin. Now see, there is one more property of gating system. There is one more property of a gating system. This property is directional solidification. Directional solidification. What is directional solidification? What is directional solidification? Do you have any idea what is directional solidification? Do you have any idea what is directional solidification? Tell me. Do you have any idea? डायरेक्शनल सॉलिडिफिकेशन किसको कहते हैं? See, what is directional solidification? I'm writing here. Okay, no problem. See, it means that firstly casting will solidify, then riser or other gating element. What I have written here is very much important. See, what I have written here is that directional solidification, it means that solidification should be such in a such manner that firstly your casting should solidify, because see here, when you have poured the molten metal, right, when you have poured the molten metal, and see here throughout this, right, see every places molten metal is there, right? And here this is the mold cavity, right? This is the mold cavity. So in this mold cavity molten metal is there, molten metal is there, and here also the molten metal is there. Now see, once the mold cavity is filled with the molten metal, now it's time to solidify. When it will solidify, we have seen that when it will solidify, there would be a shrinkage, right? There would be a shrinkage in the area, right? In the volume there will be a shrinkage, and this shrinkage would be resulting in the less less in the volume, right? Volume would be less, and see, if volume is going to be less, then we require some extra metal, so that in that gap it can be poured. So which is providing the extra metal, sir? This riser is providing the extra metal to this mold cavity, and once the mold cavity is completely solidified, then I want that my riser or my this gating system should solidify. So this is what is known as directional solidification. Firstly, mold cavity will solidify. Second, riser and the other things would solidify. So this is what is known as directional solidification, and this is very much important, sir. This is very much important क्योंकि क्योंकि यहाँ पर भी एक डिफेक्ट हो जाता है. राइजर अगर जल्दी सॉलिडिफाई कर गया तो यहाँ पर भी एक डिफेक्ट हो जाता है. दैट इज ड्यू टू द मिसरन हो जाता है, एक डिफेक्ट निकलता है. और उससे प्रॉब्लम क्या होता है? सपोज करें कि मोल्ड कैविटी मेरा श्रिंक कर गया. अब मोल्ड कैविटी जब छोटा हो गया, साइज उसका छोटा हो गया, तो मोल्ड कैविटी को और भी मोल्टेन मेटल चाहिए ताकि वो अपना साइज को अच्छे से फिल कर सके. अब वो साइज अगर छोटा हो गया, मोल्टेन मेटल और राइजर अगर यहाँ पे पहले से ही सूख गया, इट फर्स्ट पहले से ये सॉलिडिफाई कर गया, तो फिर तो आप यहाँ से भेज नहीं सकते, है ना. यहाँ से तो आप भेज नहीं सकते, और आप जब भेज नहीं सकते, आपका कास्टिंग क्या हो गया? बहुत डायमेंशनल एक्यूरेसी खराब हो गया, कास्टिंग अच्छे से हुआ ही नहीं. तो कास्टिंग पूरा आपका सत्यानाश हो जाएगा अगर आप ये बात को अच्छे से दिमाग में नहीं रखते हैं. दैट इज व्हाट? दैट इज द कॉन्सेप्ट ऑफ डायरेक्शनल सॉलिडिफिकेशन. Clear? So directional solidification is very much important because it says that firstly casting will solidify, and then riser or other gating system. Okay, so this is all about the directional solidifications. ठीक है, तो ये था सर हमारा कहानी डायरेक्शनल सॉलिडिफिकेशन का. अब हम जरा देखते हैं कि जो हमने बोला स्प्रू के बारे में जो हमने बात की अभी तक, तो स्प्रू के बारे में अब हम थोड़ा सा कैलकुलेशंस देखते हैं कि स्प्रू जो होता है वो स्प्रू किस तरह से डिपेंडेंट होता है हाइट और एरिया पर. ठीक है, तो चलिए देखते हैं इन चीजों को. यहाँ पर let us see here, that is design of a sprue. See, we have seen that sprue is somewhat like this. Okay, so what is solidification rate? Solidification rate I will define at when I will start total solidification time. These things, these concept I will start, but as of now I can say you, Shivam, that solidification rate you can just assume like that there is a rate at which solidification would be there, right? When I am pouring the molten metal in the mold cavity, so if I am pouring the molten metal in the that mold cavity, so in that mold cavity, this molten metal will solidify, and at what rate, it will solidify, that is actually solidification rate. Okay, so as of now, just now you consider this thing as a concept, but at later stage when I will define total solidification time, riser chronovis rules, a lot of rules are there, so then I will discuss these things in great details. Yeah, tell me, Subham, what is your doubt? Tell me, Subham. Just write your doubt. I'm not seeing the comment. Let me complete this topic. Okay, I will just write the type the doubt, and I will take your doubt. Okay, no problem. Now see here. So suppose this is how we will compensate the enlarged mold cavity by providing positive allowance. See, मोल्ड कैविटी जब इनलार्ज हो जाता है, ठीक है, मोल्ड कैविटी जब इनलार्ज हो जाता है तो पॉजिटिव अलाउंस तो हम नहीं देते ना, मोल्ड कैविटी जब इनलार्ज हो जाता है. सी, yesterday itself I have told you one allowance was there. मोल्ड कैविटी कब इनलार्ज करता है? When mold cavity will enlarge, suppose, just you think, yes, in yesterday class I have told you, just you think, when mold cavity will enlarge, suppose if I have put the pattern inside the mold cavity, and when I'm trying to lift that pattern and I'm unable to lift that pattern because due to the dimensional fitness or whatever is there, so I'm unable to lift that pattern. So now what I will do, I will shake that arrangement little bit so that this cavity will get enlarged, and hence the removal of the pattern will be easy. So this is the only case where mold cavity will be enlarging, right? This is the only case that mold cavity will be enlarging, right? And see, once the mold cavity have enlarged, your dimension has been changed. So for this, I have told you in yesterday class that there is a wrapping or a shaking allowance that is provided, and this allowance is negative allowance. This is not positive allowance. Always remember, negative allowance is only one type of allowance, that is wrapping or shaking. This is the same thing. So shaking or wrapping allowance is negative in nature, and if you are talking about the machining allowance, positive. If you are talking about the distortion allowance, positive. If you are talking about so these allowances are like positive allowance, and this due to the enlargement of the mold cavity, this is the negative allowance. Okay, so Subham, I think your doubt is clear. How we will compensate? So we will compensate by giving the negative allowance, right? And this case only arises when you cannot lift the pattern, and when you cannot lift the pattern, you just give a shake, you just give a shake to the arrangement, and hence the size get increased. गुड गुड गुड. तो ये चीज हमें ध्यान रखना है कि जो मोल्ड कैविटी जब बड़ा हो जाता है ना, उसमें पॉजिटिव देके तो कोई फायदा नहीं है. पॉजिटिव देंगे कैसे? वो तो डायमेंशन ऑलरेडी बड़ा हो चुका है, तो बड़े डायमेंशंस को हमें छोटा करना है. छोटा करना है. छोटा कैसे करेंगे? नेगेटिव अलाउंस दे देंगे, पैटर्न पे ही नेगेटिव अलाउंस दे देंगे कि जब हम सेक करें तो वो एग्जैक्ट फिट में आ जाए. क्लियर? गुड. नाउ लेट अस सी दिस टॉपिक, what we are trying to see here. So suppose this is my sprue. See, this is the sprue, right? See, this is the part. Pouring cup is there. This is sprue is there, right? So let me draw this. So this is, so suppose that suppose this is the your sprue, and this every part, this part is what? This part is your molding sand. Okay, here molding sand is there. Clear? This is molding sand. Entire region is filled with the molding sand. You know this is the molding sand, and this part is the sprue. So this is the molding sand. Clear? Now let us assume this to be a section 1, this to be a section 2, and this to be a section 3. Clear? Now these three sections are there. Let us assume this height to be, let us assume this height to be h1, and this height to be h3, and this height to be h2. Let it be. Clear? Let it be these heights. Okay, now see, according to law of continuity, right, continuity of mass, So continuity of mass, what I can say here is that M is equal to rho A1 V1 is equal to rho A2 V2 is equal to rho A3 V3. Clear? So this thing that we can write from the continuity of mass. So what I can say here, since the density of the fluid is same throughout, so I can write as Q is equal to A1 V1 is equal to A2 V2 is equal to A3 V3. Now what I am doing, I am applying Bernoulli's equation, at point 1 and point 2. See, when I am applying the Bernoulli's equation at point 1 and at point 2, so what I can say that P atmospheric by rho g plus what is velocity at one point. So velocity would, you have already seen that we are using see, we are using the pouring basin, right? So when we are using the pouring basin, so whatever the velocity of molten metal, whatever the velocity through which you are pouring the molten metal, at that point velocity would be zero, right? At that point velocity would be zero. So velocity is going to be is equal to zero. And see, what is the height? So if this is my datum, let us consider this to be as datum. Okay, so this to be as datum. So if this is my datum, then what would be my height? Height would be h1. Clear? Now this is equal to atmospheric pressure by rho g plus c. Now see, earlier the molten metal was at point 1. Now as soon as it will reach to a point 2, it will gain some velocity, right? It will gain some velocity. So that velocity would be, suppose, v2 square by 2g, right? And what about the height? Since this is the datum height we have considered, so this height is going to be is equal to 0. So from this equation, what I can say that this will be cancelled out, and hence we are left with a beautiful equation that is known as v2 is equal to root under 2g h1. Clear? Where q represents the flow rate, right? These things are understood to you, okay? So that's why I haven't told you. So q represents the flow rate, okay? In fluid, I think you have studied q represents the flow rate. See here, now what I can say that this v2, right? So this is the one equation that we have got. Now see, next is what? Next again I am applying the Bernoulli's equation at 1 and 3. Now instead of applying the Bernoulli's equation at 1 and 2, now we are applying at 1 and 3. So let us assume this to be our datum. So this to be our datum. Now see, if I would write a equation, there would be atmospheric by rho g, P atmospheric by rho g. See again, at point 1 velocity is going to be is equal to 0. Next is height. So what is the height? See, this is the datum, so this height would be h2. So h2 is equal to, next is at point 3. So next at point 3, so this is going to be P atmospheric by rho g plus of, let us assume that at point 3 the velocity that is gained is v3. So here that would be v3 square by 2g, and the height, since the datum is this, so height is going to be is equal to 0. And from here again, what I can say that v3 is nothing but root over of 2gh2. Clear? So now what I can say again, that A2 V2 is equal to A3 V3, and hence A2 by A3 is equal to V3 by V2, which is, if you will do the V3 by V2, see here, what is the V3 by V2 that would be there? V3 would be root over 2gh2 by root over 2gh1, and hence you will get a good relation as A2 by A3 is equal to root over of h2 by h1. Now remember this relation. Remember this relation. Always remember this relation. This is the very much important relation that I have given to you. A2 by A3 is equal to root over of H2 by H1. Okay. From this relation, direct questions are asked. Direct questions are asked in GATE. From this relation, directly questions are asked in GATE. Directly by using these equations. So till now, your every doubts has been cleared or not? You have any doubt while I was deriving this design of a sprue thing? If you have any doubt, then please tell me. Then please tell me. If you have any doubt, then please tell me. If you have any doubt, then please tell me. If you have any doubt, please tell me. यहाँ तक कोई भी डाउट, कुछ भी, तो मुझे बताएं. Okay, clear. So everybody is telling us clear. So good. Now let us solve one question. I am writing one question to you. Try to solve this question. So in a gating design, height of the sprue is 200 mm cross sectional area. Of the sprue at the beginning is 650 mm square. Next, what is given? Next thing is given as discharge rate. Discharge rate of liquid metal is 6.5 into 10 to the power of 5 mm cube per second. Now it is being asked that what is the cross sectional area? What is the cross sectional area of the sprue at the bottom? Tell me the answer. Mechanical guys, I cannot tell you kitna din ka class hoga. I think like more than 5 classes. 5 classes would be enough, because I am discussing riser design, then sprue design, riser design, gating systems. These things would be there, like solidification time, freezing ratio, a lot of things are there. So definitely it would take some time, है ना? Sir, while designing the sprue, I think you are writing sprue, if the area and height relation does not get satisfied, what will happen? See here. See here what will happen. It is being told that area and height should be like this, right? Area and height should be like this. So any change in this thing, right? So it is told that area and height relation should be in this ratio. If it is not in this ratio, then there might be a condition like this, राइट, लाइक दिस। तो बहुत ही अजीब टाइप का सर आपका शेप बन जाएगा। स्प्रू वुड बी ऑफ वेरी डिफरेंट स्ट्रक्चर्स एंड शेप, एंड सी इफ स्प्रू वुड बी ऑफ डिफरेंट स्ट्रक्चर एंड टिपिकल शेप, then there is more space for this air, there would be more space for air to pass through these cavities, and once it will pass through these cavities, more air will get entrapped, more gas defect would be there, and your casting would be your third class casting, right? Forget about the casting, forget about the casting. If you are not fulfilling the area and height relationship, then what would happen? There is a deformation, there is a deformity in the shape and size of a sprue, and when there is a deformation in the shape and size of a sprue, then you are actually allowing, you are actually inviting more air to come inside the cavities, right? And more air will come, more gas defect would be there, and you will get a very bad, poor quality of casting. Got, Chandan sir? Got the concept? Now to everyone, please try to solve this question. Try to solve this question. Try to solve this question. In the question, it has been told the gating design height of the sprue is given, right? So this is the height of a sprue. First thing that is given is height of a sprue. This is the height of a sprue. Cross-sectional area of a sprue at the beginning is given as this. Discharge rate is given as this. And what is the cross-sectional area at the sprue at the bottom? So it is being asked, right? So tell me the answer. Tell me the answer. Is it 50? Okay. थोड़ा आंसर चेक करें. Kindly check your answer. Kindly check your answer. And everybody, please try to solve this question. Very easy problem is there, only that you have to apply this concept, right? A2 by A3 is equal to root over of H2 by H1. This is the thing that we have applied, right? And just use this flow rate equation, right? And with using these two things, you can easily find this question. You can easily do the solution of this question. Try to do the solution and then I will discuss it. 50.25. Okay, Karan Singh is also telling 50.25. So for Karan Singh and Asis, I would say to kindly check your answers, that in this question it has been told to find the area of a sprue at the bottom. Area of a sprue at the bottom, right? So try to find it. Mechanical guys, I'm trying my best to cover the good material of manufacturing. See, मैन्युफैक्चरिंग एक ऐसा सब्जेक्ट है सर, जिसमें अगर आप अच्छे से पढ़ लिए, कंटेंट अगर आपके पास अच्छा है, तो आप बहुत अच्छा स्कोर कर सकते हैं. क्रिएट दैट कंटेंट, आई नीड अ लॉट ऑफ टाइम. I need a lot of time. So I always try my level best to give you the best and good content. So for this I would require a lot of time. तो मैं थोड़ा time लूंगा complete करने के लिए manufacturing को, right? So just follow my lectures. I have already covered metal cutting in the lead gate channel. If you would search Vidyapati Kumar manufacturing, then you will get the playlist of that metal cutting, and you can study the metal cutting here. And here I am teaching you the casting. Sivam has told 549.35. Why you are giving the this kind of abrupt answers? I don't know. I'm not understanding why you are giving this kind of abrupt answer. See here, see. I'm just trying to solve it, and then you just see. See, if this is the condition, what is being told, that that the sprue design, that the area at the beginning, so this is the area at the beginning, and the area at the beginning is 650 square, right? Discharge rate is what? This is the discharge rate, that is 6.5 to the power of 5 cube per second. See, so what I can write here, so what I can write here, if you are solving, then give me the answers. So if you are writing here, so this is the 650 square given, so a1 is equal to 650 square. Clear? This is the a1, this is the a1 is given at, right, this, right? Next is what is given, that height of the sprue is 20 height of the sprue is 20 So this height is given as 20 h2 is given as 20 okay. So now this is given as 20 Discharge rate of liquid metal is given as this. So discharge rate is given as 6.5 into 10 to the power 5 cube per second. This is the discharge rate, right? So this is the discharge rate that is given. Now, what is the cross-sectional area at of the sprue at the bottom? So see, this is the cross-sectional area of the sprue at the bottom. So A3 you need to find, the A3, you need to find the a3. So see, you have a very good and handsome relation between a and h. A2 by a3 is equal to root over of h2 by h1. To find a3, you need to know a2 and you need to know h2 and h1. But see, you do not know h1. Yeah, you do not know h1. So what you will do, you will use this q, and from this q you will get as a1 v1, right? Q is equal to a1 v1. Now see, you have no, it is known to use q is equal to 6.5 into 10 to the power 5 cube per second is equal to area. What is area at section 1? Is given as 650 square. A1 is given. And what is v1? Velocity at 1 is what, sir? So see, you do not know anything about the v1, so from here you will get the value of v1. So let me calculate the value of v1 to you. So see, 6.5 is given, so you can get as this thing as 1000. So mm square is get cancelled, so per second. Now see, most important thing is this is the velocity at 1. Now see, what is the relation that we have seen? So this is the velocity at 1, right? So this is the velocity at 1. So if you are knowing the velocity at 1, so see, from this figure also you can say, if you are getting some velocity, then this point is not this one, right? It should be this 2. Understood or not? It should not be point 1, it should be 2, right? Because at point 1 velocity would be 0, right? At point 1 velocity would be 0. So if I am getting some velocity, then it should be h2. So in this question, h2 and h3, so 2 and 3 point is being discussed. Now see, if I want to find the height corresponding to it, so how can I find? So v1 is equal to root over of 2g h1. So from here I will get the value of h1 as what? 1000 per second. So let me convert it at meter. So I can write as 1 by root over of 1 square by 2g. Okay, let me write it here. So 1 square by 2g, 2 into 9.81. So from here you will get the value of h1. And the value of h1 would be 50.968 Clear? So this is the h1 value that you will be getting. Clear? Now see, you know the h2, you know the h1, you need to find the a3, right? You need to find the a3. So h2 means what? h2 means s3, right? h2 means s3. So Just apply this formula. Just apply this formula. A2 by A3 is equal to root over of H2 by H1. A2 by A3. So for here that would be A1 by A3 is equal to H2 by H1, right? So it would be equal to H1 by S3. So you need to find A3. So from this equation, I can say that A3 is nothing but A1 into root over of H3 by H1. Just apply the figures. Just apply the figures, put the figures in this equation, and you will get the value of A3. Now tell me the value of A3. Everyone. Please tell me the value of A3. Now tell me the value of A3. Now it is very easy for you. A1 is given as 650 into H3 is what? H3 is 20. What is H1? 50.968. Right. Now just calculate the values and tell me the answer. So the area that I am getting is 407.173. Clear? So I think this is clear to you. This questions was clear to you, and if you have any doubt till now, then you are most welcome to ask the questions. If you have any doubt, then please ask the questions with me. I will be most welcoming you. Okay. Hello Romanji. Hello. Welcome to the platform of Unacademy, and in this platform we are discussing the casting. Even if you are of diploma, casting is very much important for even for a diploma, for a degree holder, for everyone. Everybody. Diploma के बाद डिग्री करते वक्त कौन से कोर्स करना चाहिए? See Roman, you can take the courses if you find like which is uh, course like what do you want to know about course का मतलब क्या बोलना चाह रहे हैं आप? कौन सा course? Extra course like the courses from MSME, these things. बिल्कुल कर सकते हैं सदानंद जी, बिल्कुल कर सकते हैं, 10 डाल ही सकते हैं. सी सदानंद जी, द प्रॉब्लम इज दैट in this question I was not, this is not a multiple choice question, right? So I was just attempting to get a like I was trying to get some accurate value, right? So that's why I have used 9.81. See, in the question, you will be getting the question that would be multiple choice question, right? So four options you will be there. So even if you are using 9.81 or you are using 10, you will be getting the relatively closer options, right? Closer options. So you can definitely go for guessings, right? So you can definitely use 10. Very easy, very easy. Use it, no problem. And how you have taken h3, see this is given as height of the sprue is 20 mm. See, height of the sprue is 20 mm. So what is the height of the sprue? This is the height of the sprue. So see h2, see what is the funda says, what is the funda? See here here see, earlier you were having 1, 2 and 3 sections, right? See, at but what when you have calculated, you are getting the velocity at point 1. But see, throughout the calculations we have seen that velocity at point 1 is going to be equal to 0. There would not be a velocity at point 1. So there is a velocity at point 2 and at point 3, right? So what I can understand that in the question only and only this part has been asked. In the question only and only this part has been asked. Clear? So this part has been asked in this question. Clear? Now if I would see here, then what I have done, I have made this thing. So I have made this thing. So see here, I have made this thing, right? तो ये क्या है ना, तो just now you have understood that since I will be having the velocity at point 2 only, right? Point 1 पे velocity की कोई बात है नहीं, तो अगर point 1 पे अगर मुझे velocity मिल रहा है, so this is the only thing that I am getting. Hence this is actually my h3. Okay, this is my h3. This is my area at one section. Suppose this is at area at one section, right? And area at three section, this is the area at three section. Clear? This is what is I can find. ठीक है, समझ में आ रहा है? Now everything is clear to you or not? Okay, when I will be ending the session, Roman, please let me know. I will discuss these things. Okay, मैं आपको बिल्कुल बताऊंगा, बिल्कुल मदद करूंगा. ठीक है, आप मुझे एंड सेशन के एंड में मुझे याद दिलाइएगा. ठीक है. So now this thing is clear to you. Any doubt till now? कोई भी डाउट है क्या? So now, as of now, I will end the session soon. But see, before ending the session, I will just give you some briefing of what I will be discussing tomorrow. Okay. So just I will give a little bit brief about it. So first thing is gate. Gate. That is in gate, right? In gates. What I have told to you, right? See in this figure. This is the gate. This is the gate, right? Gate or in gate. So what is this? See, this is it is the actual entry point. See, it is the actual entry point. Let me take it this laser. So see, it is the actual entry point through which the liquid metal, right? See, the liquid metal can enter into the cavity. So this is the entry point, right? This is the entry point. So entry point of the molten metal is known as gate or in gate. ठीक है. अच्छा, गेट हिंदी में गेट को मतलब क्या बोलते हैं? दरवाजा. गेट मतलब दरवाजा. आपके घर का दरवाजा जो है, दैट इज द एंट्री पॉइंट. इफ somebody wants to get inside to your home, he or she must open that gate, right? Must open that gate, and once the gate will open, then only they can pass through it. So similarly यहाँ पर भी एक ऐसा चीज है सर, entry point of the molten liquid metal to the mold cavity, that is known as gate or in gate. Clear? So what is gate, right? So let me write it here. What is gate? So it is the actual entry point through which liquid metal can be or can enter, liquid metal can enter, liquid metal can enter into the mold cavity. Clear? So this is gate or in gate. Now see, what are the types of gates? See, what are the types of gate? There are lot of types of gate are there. First type is top gate. Second type is bottom gate. third type is parting line gate, parting line gate, and the fourth part is step gate. Okay, step gate. So see, these are the some of the things which are very much important for your gate point of view also. And let me tell you, these type of questions are always asked in gate, always asked in gate. If you have a previous year question with you, you just go open the book and try to solve the question based upon this formula, right? So this is for the gate. This is very much important, very much important, very much important. Clear? Okay. Now, now see, this is the gate. So tomorrow I will discuss these things in detail, that what is top gate, what is bottom gate, parting line gate, and step gate. So firstly, try to understand what is gate. So what is the gate? Entry point through which liquid metal can enter. Now next is what? Next is next thing that I will tell you tomorrow is types of gating system. Types of gating system. So actually types of gating system, there are two types of gating system. First is pressurized pressurized gating system. Pressurized gating system. And second is unpressurized gating system. Okay, so Indrajit has told gate is asked and gate, that is quite obvious. Yes, yes, yes. Name are very similar. Okay, so pressurized gating system and unpressurized gating system. So see, what is the pressurized gating system? What is the pressurized gating system? See, the total cross sectional area, the total cross sectional area gradually decreases from choke to ingate. Now there is a new term, that is choke. Okay, so what is the choke? So see, these areas are known as choke. So I will explain tomorrow more in more detail what is choke exactly, right? So one thing that you should remember, that cross sectional area gradually decreases, right? See here, cross sectional area is decreasing from, at this point cross sectional area was more. Now gradually it is decreasing till it is reaching to the ingate, right? Now see, you have just solved the equation, you have just solved the question, right? So see, is decreasing, right? Area is decreasing. At point 1 area was more, at point 2 area was little bit, compared to point 1 it is less, and at point 3 area is compared to point 1 and point 2 it is very very less. So it means that area is actually decreasing. So see here, earlier area was what, like what, it area was like, see, firstly area was, so a1 is given as 650, right? 650 was there, so here 650 was there. And see, at a3 area should decrease, so see 407.173. So I'm getting the decreased area, so this is what is the basic concept of the pressurized gating system, that total cross sectional area gradually decreases from the chokes to ingate. And see, in unpressurized gating system, what is there, that the total cross sectional area gradually increases from choke to engage. Clear. So these three things that you should remember: C for choke, R for runner, and G for engage. Okay, so there is a ratio between choke, runner, and engage, which is very much important for throughout the things that you are going to see. Okay, so like for, if you are talking about the pressurized gating system, if you're talking about the pressurized gating system, then you will be getting area of choke is to area of runner is to area of gate would be something around 1 is to 1.3 is to 1.1. This is for a cast iron. So these ratio would be like that. So we will be seeing these things in tomorrow's session. Okay, in tomorrow's session. So throughout it, if you have any doubt, then please ask me. Throughout, if you have any doubt, then please ask with me. Otherwise, I'm going to end the session. For so I'm done with the today's session. And if you are planning for a plus subscription, then you should use my code SIRVK, SIRVK, so that you will get a 10% off. 10% off and a good smiley from me. I will help you throughout your preparation of GATE and ESE. So someone has asked the question, so let me take the questions also. If you have any doubt meanwhile, please tell me so that I can take your questions. Tomorrow class, home class at 9 a.m. Yes, Mukta ji, tomorrow I will take the class of strength of material at same time 9 a.m. Okay. And Roman, see Roman, you can do a lot of courses. You can do a lot of courses such as courses on 1 minute. You can do a lot of courses such as timing of SOM would be 9, and I will not change it. I will not change this. 9 would be there. Okay, so 9 a.m. I will teach strength of material. Okay. Shiv Kumar, I am extremely sorry. I am extremely sorry, dear, because I have told you that I will be taking the class at 9:30, because since see I have taken like approx more than 6 hours I have taken the class, so my schedule was very busy. Hence, I have taken the class at 9 a.m. So tomorrow I will also take the class at 9 a.m. So एक दो दिन थोड़ा कष्ट करिए और फिर से उसका नॉर्मल हो जाएगा. ठीक है. I will tell you everybody. Now see, for the Roman, what you have told that which are the courses that you should do. You should do the courses like Fusion 360, right? Fusion 360, or like Inventor. Inventor. If you are doing the, if you are interested in the CAD modeling, you should go to learn these things, and you can learn these things from Coursera, and that is of free of cost. Free of cost, right? So you can do the courses from the Coursera, that is a free of cost. Just you have to apply for the financial aid. Okay, so these things that you should do, because these things are very much demandable in the market. You can do to make it yourself more employable. So कोई और दिक्कत, कोई और प्रॉब्लम है क्या? कोई प्रॉब्लम, एनीथिंग, or should I end the session? So again, if you are planning for a plus subscription for 12 month, it would cost around 25,000, but if you use my code, then you will get it at 22,500. My code is SIRVK, SIRVK. You will get a 10% off. Any doubt? Any doubt? Any doubt? Tell me. and for a 24 months it would cost around 30,000. So for if you are in second or third or fourth year, you should go for a 24 months plan, and that is you will use my code SIRVK, SIRVK, then you will get a 10% off, and the discounted amount would be 27,000. So investing 37 rupees or a 60 rupees for a day, I don't think these things are very much. So you should go for it if you can afford it. Okay, so okay, so sir आज का सोम का लेक्चर अपलोड कर दीजिए शिव कुमार जी. I have you can find that uploaded, you can find that recorded lecture at the Unacademy app. Can't you find it? नहीं मिल रहा है क्या आपको? Shiv Kumar ji, just now I have checked it. Just now I have checked it, and that video is recorded video is in the Unacademy Learning app. Feel free to check that thing. Okay, वहाँ पे जाइए, आप देखिए, आपको मिल जाएगा वीडियो. Just now I have checked it. Just now I have checked it. There is a video. Okay, प्रॉब्लम नहीं होगा. ठीक है, चलिए बढ़िया. I think you guys don't have any doubt, so I'm going to end the session. Thank you so much. You have been very active. Your active participation and your active listening things have really made this session very good. So, Abhi ji, Roman ji, I have already told your doubt. I have already told you what you need to do. Especially for you, I came online. Roman sir, especially for you, I came online. I have already told you. See here. See this. I have you you can go for the Fusion 360 or the Inventor. These are the CAD modeling software. You can go for the learning of these two software, because these software are very in market, it is very in demand, and you can learn these things from Coursera. That is a free of cost. You need not to pay anything. Clear, Roman ji? Clear? ठीक है रोमन जी, ठीक है. Okay, fine. Thank you.